Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called A Tenuous Connection. A Tenuous Connection by Matt Tressel, and here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. We also have tentropy lines, where every set of 4 adjacent digits on a peach line must contain a digit from each of the x pairs, the 10 pair subsets, which is why it's called tentropy, of 1, 9, 2, 8, 3, 7, and 4, 6. A 5 may not appear on a tentropy line, and digits on a line may repeat if allowed by other rules. So as an example, you could have something along the lines of, say, what do we do here? Let's just make this 6, 3, 8, and 1, right? In this set of 4 digits, we are every set of 4 adjacent digits on a peach line must contain a digit from each of the x pairs. Well, this is from 1, 9, this is from 2, 8, this is from 3, 7, and this is from 4, 6. Now, it doesn't have to be in a specific order. It just has to contain 4 different digits, 4 different digits from each of, 1 digit from each of the subsets, which is 1, 9, 2, 8, 3, 7, and 4, 6. All the sets that add up to 10. And again, 5 cannot be on a tentropy line. Okay. And you can have repeats along a tentropy line. So remember that too. Arrows. Digits along an arrow line must sum to the digits in the attached circle. Note, all arrows in the grid are additionally 4-length tentropy lines. Okay, so that's actually very important to know. Assuming this was not an actual tentropy line. Well, no, actually we could. A possible example of this could be, say, like this is 1, 2, and 3, and this is 6. So these 3 digits add up to 6. Therefore, that fulfills the arrow portion of this. And actually, this also does fulfill the tentropy line, right? One of these digits is from 1, 9, one of these digits is from 2, 8, one of these digits is from 3, 7, and the other one's from 4, 6. So that actually does fulfill the tentropy line. It's actually very interesting. Anyways, that's how arrows work. And then we finally have the last rule, which is partial Kropke. I'm not sure why it's called partial Kropke. Digits separated by a black dot are in a 1-to-2 ratio, and not all dots are necessarily given. This is normally just given as like the black Kropke dot rule. But anyways, as an example, if this was 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We know any of these digits have to be 6, 7, 8, or 9, right? To add up to 3, with 3 unique digits adding up to it. If it's 6, it has to be 1, 2, 3, and that satisfies tentropy. If it's 7, it has to be 1, 2, and 4, and that also satisfies the tentropy line rule. If it's 8, it cannot be 1, 2, 5 because you can't have a 5 on it. But if you have 8, you could have 1, 3, and 4 add up to it. And that would... 1 is from 1, 9, 8 is from 2, 8, 3 is from 3, 7, and 4 is from 4, 6. So therefore, that would satisfy it. So if this is 6, if this is 6, it has to be 1, 2, 3. If it's 7, it's 1, 2, 4. If it's 8, it has to be 1, 3, 4. And if it's 9, it cannot include a 1. Therefore, it must be 2, 3, 4. So we know all of these entropy lines specifically have to add up, have to be 1 through 4. So these are 1 through 4. These are 1 through 4. These are 1 through 4. So that's very interesting, actually. This must contain the last 1 through 4 in this row. Right? Because one of these two, you can only have 1 doubled, 2 doubled, 3 doubled, or 4 doubled. So this is, it cannot be a combination of 1 and 2. It cannot be 2, 4 either. So this is specifically 3 or 4 with 6 or 8. Therefore, this has to be 1 or 2. If it's 1, 2, 3, this becomes 6. If it's 1, 2, 4, this is 7. So either this is 6 or 7. If this is 1, 2, 3, if this is 1, 2, 3, okay, so this cannot be 1, 2, 3, 4. So this has to be 6 or 8, which means this is 3 or 4. And therefore, this also must be 1, 2 with 3 or 4. So this has to be 6 or 7 adding up, right? Because it cannot have 2, 3, 4 because that would eliminate all possibilities there. It cannot be 1, 3, 4 because it eliminates all possibilities there. Therefore, this is also 1 or 2. This similarly cannot be, if it were 1, 2, that means all 3 of these cells see it, and therefore it'd be 3, 4, 3, 4, and 3, 4, which doesn't add, which already adds up to greater than 9, which is not possible. So it cannot be 1, 2. It cannot be 2, 4 for the same reasoning. So this is also 3, 4, and 6, 8. So this is also 6 or 7 here. Interesting. And this could actually be any of them, 6 through 9. And this could be any of them, 6 through 9. We have a 6, 7, 6, 7. Okay, so we have a 1, 2, 3, 4, 6, 8 sextuplet in row 1, which eliminates 1, 2, 3, 4, 6, and 8 from the rest of the row. This has to be 5, 7, 9. 5, 7, 9 are these possibilities. This one we're not so sure. These 3 cells, all see this cell, but that could be a 6 or 8 here, right? So that we don't know anything about that. Okay, if this is 3 and 6, that would mean both of these are 7. This would also mean this has to be 4 and 8, which would eliminate 4 from being here, which would make this 1, 2, and 3, which would force this to be 6. So then we have a contradiction there. So this cannot be 3, 6. So again, if this is 3 and 6, that forces both of these to be 7. This 3, 6 pair eliminates 3, 6 from being in this cell, which means this cannot be a 3, 6 pair. So it must be a 4, 8 pair, which eliminates 4 from all these cells, which makes this 1, 2, and 3 added together, which means it has to be 6. And the reason you know this has to be distinctly 1, 2, and 3 is they have to be different subsets along this entropy line, right? And if you have any repeats, which are allowed on entropy lines, and arrows, but the problem is you can't have repeats in just 4 digits on a entropy line, because then they would be part of the same subset, and that would break the entropy line rules. So that's why you know these have to be distinct cells on these arrows, no matter where they are, right? Because they have to have different subsets, and therefore you have to have 3 distinct subsets here, which means there are different digits, no matter what. So again, if this is 3, 6, that forces this to be a 4, 8 pair, which eliminates 1, 2, 1, 2, 4 as a possibility, which makes this 1, 2, 3. Therefore, that would force us to be 6, and then we'd have a contradiction. So this cannot be 3, 6. This has to be 4 and 8, which means this cannot be 4. So it's 1, 2, and 3. This can't be 4, 8 because of the 8, so this has to be 3, 6, which means this can't be 3. We have a 1, 2, 4 triplet there. That forces this to be 7, which makes that a 6. This cannot be 4 or 8, which means this has to be a 3, 6 pair, which eliminates 3 from all the cells that see it, which are these cells. So this is 1, 2, 4, which forces this to be 7. So this can no longer be 7. This can't be 3. This can't be 6, and this can't be 3 here. This cannot be a 7 here, so 7 has to be one of these two. 7 is also one of these 3. Let's see. These are all see these 3 digits, so it cannot be 1, 2, or 3. It can't be 4, 6, 7, or 8. This has to be 5 or 9. So since this is 5 or 9, we have a 5, 7, 9 triplet in box 3, which eliminates 5, 7, and 9 from the rest of the box. This must be 1, 2, or 3. This must be 1, 2, or 3. These can't be 6. Where can the 6 be in column 9? It has to be here. Because again, this can't be 6 because of the 3, 6 pair in the box. Therefore, this is the only place for 6. So this is 6, which makes this a 3. Neither of these can be a 3. We have a 1, 2, 1, 2 pair in box 3, and in column 8, which eliminates 1 and 2 in the rest of the box, and 1 and 2 in the rest of the column. Therefore, this is a 3. This has to be 4. Neither of these can be 4. Obviously, one of these is a 3. The other one's a 1, 2 with a 5 or a 9. So one of these is 3 here. This can't be 1, 2, 3, 4, or 6. So this is 5, 7, 8, or 9. This could be 5, 6, 8, or 9, but no 7. This sees 1, 2, 3, 4, and 6. So this is 5, 7, 8, 9 here. This is 3. None of 1, 2, or 4 are here. So this is not 6 or 7 either. This is 3, 5, 8, or 9 here. And the remaining digits are 6 and 7 have to be here, with 1 out of 5, 8, or 9. Okay, what are the remaining digits here? We have 1 out of 1 or 2. There are no 3s or 7s here. Okay, that's very important. 1 out of 1 or 2 is here. We have a 4. And we have 8 or 9 is the other possibility, right? 5 cannot be here. So 5 is one of these 3. Which means this can't be 5 and this can't be 5. And 6 cannot be here. 3, 6, and 7 are not here. 5 can't be here, so it's 4 is here. And then 1 out of 1, 2, and 1 out of 8 and 9. So we have 3 distinct sets here. And what set are we missing? The set 3 and 7. Well, this can't be 3, so this must be a 7. This also has to be a 3 or 7, so this is a 3, which means these can't be 7. 5 cannot be on a tentropy line. So this is 6, 8, or 9. Which could be any of them. So this is 3, this is 7, because we need a 1 from the 3, 7 pair in this set of 4 and this set of 4. Okay. Three cannot be, 3 and 4 can't be here, so this is 1 or 2. 3 can be one of these 3 cells here. We have 1 out of 1 or 2 here, so this has to be 5, 7, 8, or 9. I'm not sure which. Because 1 out of 1 or 2 is here, the other one has to be here, which means this can't be 1 or 2, can't be 3, 4, or 6. So this is 5, 7, 8, or 9. What else? This can't be 3. If this is 6, this would have to be 3. To be 1, 2, and 3, right? But that can't work because that would eliminate all possibilities for that cell. So this cannot be 6. So this is either 8, which is 1, 3, and 4, or it's 9, which is 2, 3, and 4. Either way, the 3 has to be one of these 2 cells, which means this can't be 3. This can't be 3, so this is 6, which makes that a 3. This can't be 3, therefore this has to be a 3 here. Which means this cannot be 7. Because if it were 7, it doesn't add up, right? You can't have 1, 3, and 3. 1, 3, and 3 because you have, that would break the tentropy rule set along this arrow. So this has to be 8 or 9, which means it's 1, 3, 4, or it's 2, 3, 4 here. So this is 4 either way. So this is 4. This cannot be 4 here. Okay, what sets are these? Is probably a good question. Oh, we know, where is the 7 in this box? We know 1 out of 3 or 7 has to be on this tentropy line. Well, can't be 3 though, so we know 7 has to be somewhere along this line. And specifically, 7 can't be here, 7 can't be here, and can't be here. So 7 has to be here in box 4, which eliminates 7 from being either of these in box 7. So 7 has to be one of those 2. Where is the 7 in row 9? Cannot be any of these cells because one of these 2 must be a 7. None of these can be a 7. Therefore, this has to be a 7. So this is 7, which means this can't be 7. We have a 5, 9, 5, 9 pair in box 3, which eliminates 5 and 9 from the rest of the box. Therefore, this must be a 7. This can't be 7, and this can't be 7. Okay. Let's color this cell, right? Okay, where is 4? 4 cannot be here or here in box 7. 4 has to be one of these cells then, which means 4 is on the tentropy line. So 6 cannot be on the tentropy line because, again, we need 1 from every 10 subset, which is 1, 9, 2, 8, 3, 7, and 4, 6. Since 4 satisfies the 4, 6 subset, 6 cannot be on the tentropy line. So 6 cannot be here, cannot be here, cannot be here, can't be here, must be here. So this is 6, which means 6 has to be one of these 3 cells and one of these 3 cells. This can't be 3. One of these is 1 or 2, and the other one's 5, 8, or 9. That doesn't really satisfy anything, though. One of these is 4, the other one's 1 or 2. So this cannot be 3, 4, 6, or 7. It could be 1 or 2. No 3, 4, 6, 7 could be 5, 8, or 9. Remaining digits here. One of these has to be a 5. Because 5 cannot be on the tentropy line. So this is either 5 with 1, 2, 8, 9. Okay. This is 6. Okay, let's start coloring this tentropy line. We're just coloring them with random colors. Orange, yellow, blue, and we're going to make that green. So then this is pink. Did I say orange? Pink. Pink, yellow, blue, and this is green, which forces this to be pink. Oh, that's interesting. Okay. So this is either 1, 2, 8, 9, 1, 1, 9, 2, 8, or 4, 6. Cannot be 3, 7 because of the tentropy line. This cannot have a 4, and it cannot be 1, 2 adding together here. Right? Because if it's 1, 2, that would eliminate all possibilities for that cell. Cannot contain a 4, so it cannot be 2, 4, 4, 8. So this has to be 3 and 6. Therefore, 6 is removed from the rest of the box because of the 3, 6 pair. Also from the rest of the column. So this can't be 6. This can't be 6. And this can't be 3. Well, we have a 5, 8, 9 triplet in box 2 now, which eliminates 5, 8, and 9 in the rest of the box. So this can't be 5, 8, or 9. It has to be 3. This can't be 5, 8, or 9, so this must be 6. Therefore, this is the same set as that, which is subset, sorry, which means it has to be 4. So this is 4. This cannot be a 4, 6 pair. So this is 1, 2 with 8 or 9. One of these has to be an 8 or a 9. So that means an 8 or a 9. Okay, this can't be 6 either. So therefore, this is a 6. One of these is 1, 2, 8, and 9. The other 8 or 9 has to be here. And these can't be 4. So therefore, this is a 1, 9 or 2, 8. Either way, there's an 8 or a 9 in this pair, which means this is 8 or 9, which means 8 or 9 cannot appear in the rest of the column. So this has to be a 1 or 2 to match 1, 2. And then we have a 1, 2, 8, 9 quadruplet in column 5, which eliminates 1, 2, 8, and 9 from the rest of the column. Therefore, this must be a 4, which means this can't be a 4. The remaining digits now are 5 and 7, so this is 5, 7, this is 5 or 7. 4 has to be one of these two cells. We're not sure which. So one of these is a 4. One of these is a 7, and the last remaining digit is a 1, 2, 8, or 9. But we're not sure which. Well, we have a 1, 2, 1, 2 pair in row 7, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2. This can't be 1 or 2. The remaining digits have to be 5, 7, 8, or 9. This also has to be 5, 7, 8, or 9. Therefore, we have a 1, 2, 1, 2 pair or sorry, a 5, 7, 8, 9 quadruplet in column 4, which eliminates 5, 7, 8, and 9 in the rest of the column. Therefore, this must be 1 or 2. This must be the green 1 or 2 here, which means this can't be the green 1 or 2. It has to be the green 8 or 9. Since this is an 8 or 9, and one of these is a 5, and one of these is the other 8 or 9, this cannot be 8 or 9. So this is the pink 1, 2, which forces this to be the green 1, 2. This is the pink 1, 2 also. This also has to be the pink 1, 2, and this is the green 1, 2. This then has to be the green 1, 2, so this can't be 1, 2. It has to be 3 because it sees the green and the pink 1, 2, so this is a 3, which makes this the green 1, 2. This is the green 1, 2, which forces this to be the pink 1, 2, which means this is the green 1, 2. Now we have a 1, okay, so this can't be 3 anymore here, and we know one of these has to be a 3, therefore this is a 3 here. Well, we have a 5, 8, and 9 triplet in box 9, which eliminates 5 and 9 from the rest of the box. This can't be 5 or 9. It's a 1 or 2, and it's the pink 1, 2. We have a 1, 2, 1, 2 pair in row 7, which eliminates 1 and 2 from the rest of the row. So this can't be 1 or 2. Therefore, and 5 cannot be here. Where is the 5 in row 8? It has to be one of these two cells, which eliminates 5 from being here. Also, one of these has to be 7, because in column 4, where is the 7? It can only be one of these two cells. Therefore, this can't be a 7, which forces this to be 5, which makes that a 7. Therefore, again, this can't be 5. We know now this is a 7. One of these two is a 7. And one of these has to be a 5, because where is the 5 in column 4? It has to be one of these two cells, which means this can't be 5. The remaining digits here are 4, 8, 9, and 5. Because one of these is 1 or 2, this is a 1 or 2. This can't be 4, obviously. The pink 1, 2 has to be here. And this has to be the green 8, 9, right? So this adds up to 10, because this adds up to 10 here. This is the pink 1, 2. So the pink 1, 2 cannot be here, cannot be here, cannot be here. It has to be here. So this is the pink 1, 2. Since this is the pink 1, 2, it sees both of these. So this cannot be the pink 1, 2. It has to be the green 1, 2. And therefore this can't be the green 1, 2 because it sees both. Therefore this is the 4. This has to be the green 1, 2. So this is the green 1, 2, which makes this the pink 8, 9. Because we need one green and one pink on this line, and that has to be the green, which makes this the pink. So this cannot be the pink 8, 9. It has to be the pink 1, 2, which forces this to be the pink 8, 9. We also have an 8, 9, 8, 9 pair now in row 4, which eliminates 8 and 9 the rest of the row. This can't be 8 or 9. This can't be 8 or 9. This can't be 4, so this is 5. This can't be 5, so this is 6, which means these can't be 6. Whereas the 4 in column 6, it has to be here. So this is 4. This can't be 5. And it has to be the green 8, 9 here. Well, we have another 8, 9, 8, 9 pair, this time in row 6, which eliminates 8 and 9 from the rest of the row. Therefore, this must be a 5. This cannot be a 5. It has to be the pink 8, 9 because we already have a green 8, 9. The pink, where is the pink set in this entropy cell? Cannot be either of these because we have the pink 1, 2, and 8, 9 here. Cannot be pink 1, 2, so one of these has to be the pink 8 and 9. So one of these is the pink 8, 9. What about the green? This cannot be green either way because this is the green 1, 2. This is the green 8 and 9. And therefore, this can't be the green either one. And it has to be the green 8 and 9 in one of these three cells. But this is only pink or green, so this must be the pink, which forces this to be the pink 8, 9, which means this is not the pink 8, 9. So the green 8, 9 is one of these three. The green 1, 2 is one of these two. So we have an 8, 9, we have a 4, 7, 8, 9 triplet, or quadruplet in box 7, which eliminates 4, 7, 8, and 9 in the rest of the box. This can't be 8, 9, this can't be 8 and 9. One of these is the green 1, 2. And this cannot be the green 1, 2. We have a 1, 2, 5, 8, and 9 quintuplet in row 3, which eliminates 1, 2, 5, 8, and 9 in the rest of the column, or row. So this has to be a 4. This cannot be green 1, 2. Where is the green 1, 2 in column 1? It can only be here. So this is green 1, 2, which means this is not a 5. So this has to be a 5 because that's the only place for it. This 5 means this can't be 5. So this is 9, which makes that a 5, which makes that a 9, which makes that a 5, which means this can't be 5. This cannot be green 8, 9, so it's pink 8, 9. This then must be the green 8, 9, which means none of these can be the green 8, 9, so this has to be the green 8, 9. Therefore, this is 7. This has to be 4. This can't be 7. And this must be a 7, which means this is the pink 8, 9. Which means this can't be pink 8, 9, so this must be the pink 8, 9. This is the green 8, 9. We have a 1, 2, 1, 2 pair in row 2, which eliminates 1 and 2 from the rest of the row. Okay, pink 8, 9 cannot be here, cannot be here, so it must be this cell. So this is the pink 8, 9. We have an 8, 9, 8, 9 pair in column 1, which eliminates 8 and 9 from the rest of the column. So this must be 5, which means this cannot be 5. It must be the green 8, 9, which must be 8. So we can mark all the 8 and 9s as 8. And we're going to remove those greens so that we can just get 1, 2s, and therefore those must be 2s. Then we'll mark the 1, 2s that are remaining as 1, and the 8, 9s that are remaining as 9. Except we don't know that one. This one can't be a 5, so it is, well, that can't be the green 8, 9. That has to be the green 8, 9. So these are the pink, which are 9. This can't be 5 or 9, so this is 8, which makes that a 5. This can't be 3 because of this 3, so this is 6, which makes that a 3. 6 cannot be either of these two, so this must be the 6. Digits remaining here, this has to be a 2. We have, what, 1 and 8. This can't be 8, so this is 1, which makes that an 8. This can't be 7, which makes that a 5, and therefore this is a 7. And that's how you solve it. Yeah, pretty straightforward. Actually, I didn't think it was that challenging. Yeah. It's just, I mean, you have to know the Tentropy, essentially, rule set, but that limits things quite a bit. Especially with the crocky dots in the certain positions. I don't know. I would consider this probably easy, but that's just me. Anyways, I hope you had an easy time of it, and I'll see you next time on Frank Puzzles. Take care.